Welcome to this lesson on electromagnetic induction. Today, we will explore how to calculate the induced electromotive force in a rectangular coil when the magnetic field changes over time. We will also discuss how to determine the direction of the induced current using Lenz's law. Here is the question we are focusing on. A rectangular coil of 50 turns at a cross-sectional area of 0.02 square meters is placed in a uniform magnetic field. The field changes from 0.3 Tesla to 1.2 Tesla over 2 seconds. The coil lies perpendicular to the field. We want to find the average induced electromotive force in the coil over this 2-second interval. Then we must state the direction of the induced current using Lenz's law. Next, let us recall the relevant equations. Magnetic flux phi equals B multiplied by A for a uniform field perpendicular to the coil area. Faraday's law states that the induced electromotive force equals negative N multiplied by the change in flux divided by time. Let us begin with part 1. First, we calculate the change in magnetic flux. The magnetic field changes from 0.3 Tesla to 1.2 Tesla. So the change in B is 1.2 subtracted by 0.3, which equals 0.9 Tesla. The coil's area is 0.02 square meters. Therefore, the change in flux is 0.9 multiplied by 0.02. That is 0.018 Weber. Next, we multiply by the number of turns, which is 50. So the total change in flux is 0.018 multiplied by 50, which equals 0.9 Webers. Since the time interval is 2.0 seconds, the average induced electromotive force is the total change in flux divided by the time. That is 0.9 Webers divided by 2, which gives 0.45 volts. Hence, the average induced electromotive force is 0.45 volt. Now for part 2. Lenz's law tells us that the direction of the induced current is such that it opposes the change causing it. Here, the magnetic field is increasing from 0.3 Tesla to 1.2 Tesla. The coil will generate a current that creates a magnetic field opposing this increase. This means the induced current flows in the direction it tries to reduce the rise in flux through the coil. To summarize, the average induced electromagnetic force is 0.45 volts. The direction of the induced current is such that it opposes the increase in magnetic flux in accordance with Lenz's law. Thank you for watching this tutorial. Be sure to review Faraday's law and Lenz's law to handle similar problems.